This is the enter time module, which is going to keep track of the user's input and then assign it to hours, minutes, or hours, minutes, or seconds. So, yeah, here's initializing all the registers, wires, and more registers. Here's initializing all the registers to 0, because nothing has value yet. And then here onto the important stuff. So basically, what the value variable does is that's the user input. And basically, depending on the mode, 1, 2, or 3, it will assign that value to either seconds, minutes, or hours. And if the value exceeds the max value for that unit, like 59 for minutes and seconds, or 23 for hours, it will automatically just set it to the highest value. And then over here, we've got hours times F and various other F registers, which will choose between either the C wires or the D wires on what to display to the 7-second display. So basically, the C wires represent the values from the clock. The D wires represent the values that the user is inputting into the clock. So basically, it will choose the D wires when the user is inputting values into the clock so that they can actually see the numbers that they're putting in there. And the C wires are the clock increment or the clock values while it's actually ticking. And that triggers when the mode is equal to 0, which is the clock mode. And so over here, basically, the F registers are then sent to the output, which are then sent to the 7-segment display later on. And over here, we call the clock to get the values for the C wires, and the decoder to get the values for the D wires. Here's the clock module. It's pretty self-explanatory. We use switch in mode to keep track of whether the clock is on or off. And then these are inputs from the user, as well as outputs that are then sent to enter time. Basically, there's a clock that keeps track of when to increment seconds. So basically, we found, instead of 10 to the 9th nanoseconds, it was actually found that 10 to the 11th nanoseconds was equal to 1 second. So we set that for that number of cycles, and then each time we reached 100 million cycles, we would go ahead and increment seconds by 1, which then increments the rest of the clock, minutes, hours, eventually, and then resets it to 0 when it reaches the max. And the decoder doesn't really need to be explained. It's pretty simple. Basically, it just separates every single value into singular digits. So basically, like, if it's just 6, for example, it'll keep it that way. But if it's like a number like, two-digit number like 24, not 24, you can't get that. If it's like 23, it would separate that number into 2 and 3 so it could be displayed on the 7-segment display.
This is the top module that contains the waveform generation modules for the different sounds that the system is able to produce. They can be controlled by the user to indicate which one they want to output, and also instantiated is a 25 megahertz clock divider, as the frequencies are set up to receive that input signal. And if the input signal is not 25 megahertz, the output audio is very distorted, either much higher or much lower. So this is an example of one of the sound generation modules. This one is creating a sound that resembles something similar to an ambulance siren. And as you can see, it's hard-coded to output a high signal at specific values of the tone variable based on the 25 megahertz clock input. So initially, I wanted to avoid hard-coding the sound output modules, and I wanted a way to be able to implement my own custom audio files, and I found a way of doing this in a book by Simon Mogg, which discussed a .wave file player module, and initially it looked promising. However, it required recording your own audio clips in third-party software, exporting them as binary files, and running them through a Python script to get them in individual lines of hexadecimal numbers. And it just became extremely difficult to find out where errors were coming from and debug the whole system, as well as dealing with the memory issues that came along with reading that many lines of hexadecimal numbers into a variable. And so I decided to move forward with a more simpler approach. To allow the user to input different values for the seconds, minutes, and hours, there's a mode switch that allows them to set each individually. And once the clock state is set to 0 and the start switch is set, the clock will begin to run. Taking some inspiration from a digital radio alarm clock, the system is also able to output various sounds based on what the user switches. Here is just some more footage of our clock running to demonstrate how each of the values roll over as they reach their maximum.